Okay, welcome to Nested Loops. I'll just go over, we're doing part 5, design patterns, explained, second edition, chapter 14, and we'll just turn it right over to Diego.
All right. So pretty much this is so in this chapter, the author pretty much goes over the principle that we can learn from design patterns and how we should think about design patterns in general. So it starts with, it's going to describe the open-close principle, which underlies many of the design patterns, designing from context, which is pretty hard to do. Principle encapsulating variation, which is what drives a lot of the design pattern in general, which essentially you're trying to encapsulate variation so that your code is open for can handle changes in the future. Difference between abstract classing interfaces, and causes with the need to maintain a healthy skepticism about patterns. And pretty much say they're helpful guides, but they're not truth. And actually the term that he uses is they're abstraction of truth. But then you have to implement your own truth, pretty much. Okay. Who's not muted? Scott?
I'm not muted, but am I making noise? Oh, Scott's moving around. Scott's still sitting up.
All right. All right, so see, let's click over here. The open-close principle. And pretty much what it aims at is be able to extend software capabilities without changing. And in theory, is very, very simple, which is open for extension, closed for modification. Which means that it sounds like a counterintuitive, but you can add new implementation without changing the existing classes. That's what it is. And the emphasis is existing classes. It's like whenever you extend, like some of it, like when I first heard this years ago, open for extension, closed for modification, I was like, how is that possible? You gotta add code someplace. The thing is, like, you don't add code to the existing classes. You add code to new implementation. And actually, you can over here. You can add new functionality in separate distinct modules, new subclasses, and integration. But actually, like, whenever you add these new classes to these other modules, here says that the integration cost is the minimal because since you haven't changed the existing class, you are not disrupting the system. So it's usually not possible to follow the open-close principle completely, but as a goal, it's the right thing to be aiming for. In my experience, but that's pretty correct. Again, I kind of follow like a little bit of Yagni, a little bit of like a rule of threes. That generally my code doesn't end up being open-close until it's being used a little bit. So I start with something that, and I might try to do some guesses for what is gonna change, but probably I'm not as methodical as the author. And like when doing like analysis of what varies, and we're gonna go in a little bit later. So, but pretty much that's what the Bertrand Meyer idea is. Try to adhere to this concept as much as you can, which is the all in solid design. All right, so the principle of designing from context. So it goes back to Alexander, and he said, okay, like when he talks about, see, I hear an echo behind me. When he talks about architecture, he's like very, very good at finding a context every single time. But whenever in code, it's not quite as simple. And part of it is because you can, how to explain this? There are many different levels that you can approach the context from. And so we pretty much like it goes by, like you find it quite often by asking the right questions. So he says he starts with the service orientation, asking what kind of service do we need to provide. And because he's defining from the need of the abstraction class, I must define the service at an abstract level. So he looks at it from the needs. Hold on, I lost my train of thought. Did I misread this? All right. I think I misread what it meant here. Sorry, guys. All right, I'm gonna have to reread this because I just confused myself. All right. Anyway, maybe I'll just jump to the dependency inversion principle because I misunderstood what he's talking about. So in the dependency inversion principle, again, part of it is because he approaches it from the point of the service being provided. Pretty much it says, and he pretty much looks at it from a high-level point of view, and say like, I should not depend on low-level module. And like, so high-level abstraction should not, or module, should not depend on low-level module. Both of them should depend upon abstractions. And it's like, probably like better represented in the bridge pattern. And abstraction should not depend on details. Details should depend upon abstractions. And yes, okay, there it goes. And this is like the concept of complexification, which means you start with the simplest level and gradually add details and features. And part of it, I think, I don't know how everybody feels about it, it's kind of normal to do this because when you start, you don't have a clear idea of what you're building and how it's going to be built. But I guess like the way he looks at it is it's also a guideline, meaning he asks himself quite often if he's looking at the correct level of complexity, right? Am I looking like it's quite easy when you code to start at the right level, a high level thing, and then I need like this one thing to get to the next portion or next step in my code development, and you start reaching into details, and like pretty much keeping it as a principle of keeping everything at the same level of details. And is a much more deliberate approach. And also it implies that over here, the coupling between the using object, the clients, and the used object, services, is done at a conceptual level and not at the implementation level. So over here, like it goes again to the CAD problem. You know, when it looks at it, oh, this is is drawing shapes, and there's different implementation of how it's going to draw the shapes. What is the software really doing? Is this a piece of software that draws, like, what is the abstraction? The abstraction does not revolve, or the context does not revolve around the different implementation, but about the fact that this software is drawing shapes. So the abstract classes and all the abstraction are about the shapes and not about the different implementation of how each line or whatever is being created. Also, when it goes to details, like when I say I want to look at my needs to draw shape, I might regularly identify line and circles. And if you ask yourself, what shape do I not support? I'll notice that it doesn't support ellipses. So it has like different options. You know, implement another method to draw ellipses in addition to line and circle. Make circle a type of ellipsis. That's what it is. Or say diagonal. I'm not gonna need it. Or I don't need it yet. So don't implement it. The cost is greater than specific. The other thing is it's important when designing classes within context to represent the same external behavior. And this is branch is a list of substitution principle, which means like the client, when it receives this object and uses this object, should not care what kind of object it is, right? So if you substitute the object with an object of different class, they're still compatible. The interface should be the same. You cannot change and everything should behave about the same. Even though, you know, the end effect is going to be different, for the client, everything about it should be completely transparent. Because all of those details have been encapsulated and hidden away. Or again, in the previous example, say whenever you identify opportunities, it doesn't mean that you have to follow them and implement them. And that goes, I personally feel that it goes both on, like we have an opportunity to add methods for stuff that might happen or whatever. There is a type of opportunity, and that type of opportunity could be also trying to design from some kind of variation that may occur, but is unlikely. Doesn't mean that you have to design or implement some kind of like super flexible system for cases that only you have come up with. Like, as developer, we can come up with stuff or like with ideas that may never occur. So, any questions so far? then it talks about pretty much every single design pattern, and talks about the context of each design pattern. So it's a content abstract factory. So this is a good example of design by context. I understand early on the factory object of some sort would be used to coordinate the instantiation of family of objects. But there are many different ways of doing it. You can use derived classes. You can use a single object that pretty much has a bunch of switches, configure a file with switches, or a mix of all the things. And so how do we decide? Well, you have to take, depends on the context, the likelihood of future variation, the importance of not modifying our current system, the language, who controls the sets of objects, or whether like is like a user, we do it, like am I the only developer here, and the availability of database or configuration file. Like if we don't have that, of course, this solution doesn't apply. If we know this is like a one and done, maybe we don't need to go too much further. And again, it goes back to YAGMI. Like you're not gonna need it in some cases, or like sometimes have a single object with switches is good enough. And in some of this context has nothing to do with the context of the class, but or the context of the development environment. So the way he goes about it is instead of asking which of these implementations is better, it says under what circumstances would this alternative be better than the other alternative, and which of these circumstances is most like my current problem, right? So again, I definitely don't do this, but it's definitely a good I think it's a good internal exercise to do, to ask yourself quite often, like, under which circumstances this is better than that. It's like, one design pattern is generally not better than another. It's like they have different use cases, and sometimes you're going to use one over the other for more the circumstance of the development more than the software many times. And I think like actually doing like these pros and cons of each alternative, it's like doing every single time might produce a better result in the end. Although I'm pretty sure it's pretty tiny. In the concept of the adapter, pretty much it's a very illustrative design for the context for content, because it always shows up within a context. So potentially you say you want to convert an interface, an existing interface, into a different interface, and generally have multiple adapters that they need multiple adapters. They need to implement one interface, and that is the context in which the adapter is used. The facade is kind of funny because I feel the facade is like an ever-changing class. This is AI actually talks over here. Facade is often developed incrementally because potentially like you don't know what you're gonna need until you use it. And again, as a reminder, facade is a simplified interface to a complicated interface. So you use just a subset of what the API provides you. Like for us, like we use a facade for stuff we do for PayPal. PayPal has a bunch of different API calls, but we only need 4 or 5. So we have a facade class that we use, and we might have started with 1 or 2 calls, and then we added a few more as we saw. Oh, we need some other stuff. Let me see. Over here, well, this is a personal note about him that pretty much by teaching design patterns, he found himself involved in many more projects they would have as a developer. And yeah, it found like the certain context are defined not in the typical way that you expected. All right, the principle of encapsulating variation. So again, there's a note on his own design where he talks about the pretty much he rarely has inert hierarchies that go more than 2 levels of classes T. And generally, whenever it goes deeper than that, it's stuff like a decorator pattern. And the reason why it does that is pretty much it's like one of his design goals is to never have a class that contains 2 separate issues that are varying unless the variations are explicitly coupled to each other. So again, it might separate, like I guess, the interface from the abstract class from the implementation class. So, and part of the encapsulated variation, again, you want to encapsulate variation because you want to encapsulate whatever changes. So it talks about encapsulated variation in the bridge pattern. It's an excellent example of encapsulated variation. The implementation present in the bridge pattern are all different, but are accessed through a common interface. And new implementation are added within the interface that's already been provided. Abstract Factory, again, in the abstract factory, the encapsulation is of how the classes are being instantiated. Going back to here, you're using the right class. Let's say if you start with an abstract factory, and the encode inside the abstract factory uses a single object with switches, and then later on you decide to use derived classes or switch the configuration file. None of the code that uses the abstract factory cares, because you have encapsulated a way how you're going to create the objects. So that, like, what varies is how to create the object, and again, you encapsulated how they are going to be instantiated. The adapter pattern, again, pretty much it's like what changes is the actual object, and because you provide a common interface, you're encapsulating the actual objects that are changing. Facade, say, does not encapsulate variation. Let me see. It does have an example here. That sometimes okay. So you have generally you have you're trying it's a simplified version of a subsystem, but then another subsystem comes around, and the facade now becomes a mix of facade and adapter. So patterns are not just about encapsulated variation. However, they also identify a relationship between object and assist in thinking about the essential concept in the problem domain. So like in the bridge pattern, it says like it doesn't just provide encapsulated variation in the abstraction and implementation, but also like a relationship between the abstraction and the implementation. But I don't know many other patterns that do that. Of course, do you know other patterns that do that? They work like a bridge pattern, that define different relationships. Are you muted?
I know. Hey, no, offhand, I can't think of it. I have to think about. But
maybe if I look at the Gang of Four book, I can find it. But off the top of my head,
one of those other ones deal with not quite the relationships, but some of the harder one is, what is the double dispatch pattern?
Oh, yeah.
You know which one I'm talking about. It's the pattern that's about double dispatch. It's not quite that, but it is like many to many kind of relationship.
Okay.
You know which one I'm talking about. I can't think of the name of the pattern. Not visitor or something. I'll look it up.
The visitor?
No, visit.
No, I don't remember all. Anyway.
Okay. Yeah.
All right. So this just goes in discussion with the abstract class and versus interfaces. There's a little note about how interfaces are also language. So interface has two different. It's a loaded word, right? Overloaded word. One is generally, even with the abstract classes, you design an interface, an API to this class. But there's also like the interface, like Java interface, C#, all that, where it's an actual construct of the language. So it goes into the difference between the two. I say, so abstract classes can be viewed as a way to bring together related entities, and how this implementation encapsulate them. And pretty much when you do this, you also provide hold on, let me see. Okay. And practically, by doing so, like you also provide the interface to whatever object you're doing. And practically to design what the method, the interface of the abstract class is going to have, you're going to say, what is the interface this thing must have in common so they can be used in the same way. Now, and this is from,
is that
it's centered around the client object. So it's centered around how the client of this object, client is going to be using this object, is going to interface with this object.
Yeah, those two sentences, or that sentence, that reminds me, isn't that how you're supposed to do normal OO development when you figure out the class, arguably the abstract class? You're trying to figure out what is the interface that all the related things will use.
Yes.
When I see that, I go, isn't that object-oriented 101? Kind of.
So I think like one way to look at it is it's like he does a distinction here a couple of times. One is viewing things from the service object, and viewing things from the client object. So service object being the objects that are being used by others, and client object is like what is actually interacting with this service object. And generally, like when you do abstract classes, I feel you're thinking more of the service object, like what the object needs to function. Whereas when you think about interfaces, because you start with the client object, meaning and again, it's two different approaches, because in most languages you get only one shot at abstract class, right? You can only inherit it from one class, right?
Yeah.
And if you use the least code substitution method, it means that none of the subclasses are going to add any methods that the parent class is not going to have. But they all share the same exact API.
Well, no, they can add stuff. The key is you can't expect them to act in a different way with the public interface of the abstract.
Right.
So they can have methods as long as the public methods of abstract act in the same way. And I think Uncle Bob has a really good example where I can't remember. He subclassed square from rectangle, and one of the common math things didn't work right on that interface. And he said, "Oh, it makes sense because in reality, a square is a subset of rectangle. But when this method is called on square, it doesn't give you the answer back that you expect or something." And so it's not that you can't add new methods, you just can't respond to the abstract class methods in a fashion that's unexpected from anything else in the class.
Okay. All right.
If that makes sense, that's hard to wrap your mind around. But once you go, oh yeah, we should actually study that book. I think it's Agile Software Development by Uncle Bob. He has that example. But go ahead.
All right. So and then it goes like, if you start with the client object and you think about interfaces rather than, first of all, interfaces, you can implement multiple interfaces. And by starting with the client object, you can differentiate in the used object into smaller, like maybe it's not just one set of APIs call, it's multiple. So you say like you might end up with smaller, more thinner interfaces. And then again, it goes back, the one is not necessarily better than the other. One approach is not better than the other. You always have to kind of counterbalance and evaluate the two, the two options. Like throughout the whole book, pretty much, it seems to me that he goes and says, and I think that in the next paragraph, there's a little chapter. Because he's always skeptic. Like he has the healthy skepticism. He just says like, a useful guide by dangerous scratches. Like you cannot take this as truth and apply them, or even have favoritism. Actually, I used to work with somebody that liked certain parents and disliked some other ones, and it was like a very strange thing to deal with. And parents say or like you cannot think of, oh, this does not match exactly how the parents work, or trying to retrofit the parents to something, or like everything needs to be a pattern. So don't think about it, like they're guidelines. So like you should, it's not a religion, not everything needs to be a pattern. The abstraction of truth, and potentially they need to be associated with real world data, right? And then it goes like there's 5 general problems or errors that happens. Superficiality is when you're too quick at selecting a parent because you don't have a full understand of the system. Bias, when it's like pretty much you might pick or like you think that you have a favorite pattern, and you try to funnel everything through that pattern, right? So maybe you know the adapter pattern, you know the bridge pattern, and you try to build everything as adapter and bridge pattern, or decorator pattern. Like maybe you need just a body object. Who knows? The selection error is like it doesn't understand context and condition, define when a pattern is appropriate, and therefore you select the wrong pattern. Misdiagnosis, which is again you're not familiar with the entire collection of patterns, so you don't you select the wrong one because if you know 5 of them, those are that you might end up using all the time. And fit, which is pretty much there might be exceptions, they don't apply, but you just ignore them because they don't fit your pattern that you pick. So yeah, that's about it. Again, it talked earlier. Remember, the patterns are discoveries and not invention. So this is, I don't know how to explain this sentence.
Yes, right.
I kind of get it. It's kind of you need to like I think it's kind of like a square peg in a round hole thing. It's like the pattern that is right for your problem it's in the problem, you'll see it, it'll fit just right, and it's not something that you're gonna like force it upon.
Yeah, in the Gang of 4 book, they talk about every pattern that they picked was independently derived by like 3 different groups.
Mm-hmm.
So it's a pattern because we see, 3 different groups of people that actually know how to program came up with this solution, i.e. this is a pattern that occurs. To kind of go to Alexander, this occurs in real life, so this is what you have to do. Right, and so for the pattern to exist in the Gang of 4, and they come out and say, this is not every pattern there is, these are just the 24 that we picked out of whatever case studies they did. These are the patterns that show up for these kind of conditions, or a solution that matches these kind of conditions. And so they make a big thing about there not being invented things. Like, look, well, these are ones that like multiple people come up with. These are the patterns we see in these situations. So when he talks about the solution, the pattern that you pick depends on what the problem is, for sure.
Mm-hmm.
Right. If I need a command object, I don't make a visitor. If I need to encapsulate different kinds of actions, then maybe it's command or strategy, depending on how that works, right? It's certain scenarios, there's a certain answer for it.
All right. So it goes into the summary, say like 2 powerful strategies are designed from context, which I don't think it's easy at all. And the capture variation in class becomes a little more natural. And pretty much it's like this strategy enable us to defer decision until we can see the ramification of what these decisions are, right? And part of it, like the way I see him doing it is by evaluating the difference and the impact of each pattern. It pretty much it fleshes out what the ramifications of the decision are, right, ahead of time. And again, it elaborates on the capsulated variation. It says like it it can accommodate many future variation, but also it does not try to make everything, all of its design general purpose, because if you try to, the here says like trying to accommodate all possible variation, typically leads to not having a system at all. So it's like too generic. It doesn't actually. It's either too generic or you're never gonna build it, which is this is called paralysis by analysis. Yeah, I'm trying to evaluate every possible thing that changes and start redefining integers at some point. So again, the principle has gone over the open cost principle. This is an open for extension cost for modification. Dependency inversion principle, the high module should not depend on low module, so both should depend upon abstractions. And help is skepticism, which is like be careful to over rely on parents. Use them to help you think about the problem and not take them as gospel. So in the view questions, so when it comes to choosing how to implement the design, what question should you ask? This is the one that was asking, still asking implementation is better. Ask yourself under which circumstances this implementation is better than this other one, and which of these circumstances is the one that I'm in right now.
Yeah. I think that's tough. A lot of times I think you don't know the answer at first. And so I think you pick the easiest one, unless it's obvious. Sometimes it's obvious or semi-obvious, and sometimes you have no idea. You just go, well, let's go with the easiest one and see how it works.
Right. What the 5 possible errors of using design pairings are, superficiality, bias, selection, misdiagnosis, and fit. Where you either don't know enough about the problem, or you haven't analyzed the problem enough. You have a bias versus one one parent versus the other one, or you have selected the wrong parent, or you have enough knowledge of all the parents, so you can misdiagnose the problem, or you try to ignore some edge cases because you don't fit your parent. The open close principle says modules, methods, and classes should be open for extension, while closed for modification, not modification. Pretty much this is a way to minimize risk when changing system. So we want to be able to extend the capability of a system without changing it. So pretty much we design. The point is to design the software in such a way that we can have new variation without introducing new fundamental structures.
Yeah.
In what way does the bridge parent illustrate the open-close principle? Because you had new implementation without changing any of the existing classes. You just add new implementation every time. Even though a design parent might give you insight into what could happen, you don't have to build your code to handle those possibilities. How do you decide which possibility to handle now and which to be ready for the future? That's a good question. Personally, I generally know which one I need to handle now. I don't know how much I do for the future stuff. I used to do a lot more generic coding and say, oh, maybe we'll do this, maybe we'll do that. And I found out, like, if I were to guess, more than half of the time, never end up using those.
Yeah. Premature optimization.
Right. Easily, more than half. I don't know much more, but
I think you need to look at the schedule.
Yeah.
Sometimes you know it's happening 6 months from now, then you plan for it.
Yeah, and also how long will it take me to do this other implementation, right? Or handle this other procedure. If it's an easy thing, you do it. If it's easy, and like if I'm on a rush, give a concrete example of danger of misapplying a design pattern based upon your current work. Misapplying design pattern. I think well, I don't have a misapplying design pattern.
Do we have a lot of patterns in our code? I occasionally use composite because it's super applicable to some things.
Mm-hmm.
But obviously that was the right pattern if I used it. So
I think there's an overuse of decorator pattern in our base code, and an underuse of adapter. But I don't know if misapplying.
Well, I think in general, if we misapply, the problem is you have to undo it once you realize it's not the right thing.
Right.
And generally, if you add a pattern, you add complexity. So it'll become technical debt that's harder to remove than if it wasn't just a plain old object.
I think like the way some of the code that I've looked at recently, generally it's like there's been a misapplying of design pattern. There've been like the dependency inversion principle was not followed. Like there's high modules that depend on low level modules. I see that a lot.
Yeah.
And vice versa. I also see low level modules. Like I see those, and then I'm thinking, oh, this program pattern here will fit this. That will probably solve it. Anybody else want to chime in on that one?
Yes. Don, you've done some code. Any opinions?
No. I guess I'll say that we don't, out of these patterns, we don't use them very much. But obviously we use model view controller and everything because it's built like kind of baked into our stack, right?
Mm-hmm.
Which one?
Model view controller.
Right.
Yeah. Well,
and then by extension, we use some adapter, all that stuff that's kind of built into frameworks.
I'll say the ones that I use or have used often. Composite, there's a certain sequence, and if you've ever done a lot of GUI work, that just makes sense. Composite, I've used a lot. Strategy command pattern, I've used. Occasionally facade. Adapter, decorator, those are good. No object actually is something I like to use a lot if I can use it.
Null object?
Yeah.
Yeah.
No object's a good pattern. And again, it's not one of the 24, but it was made like the honorary 25th pattern.
Yeah, it's an easy one and very helpful.
But it's very clean for OO coding. Those are the ones. Some of the ones, visitor, no. Interpreter, ever since you use Ruby, you don't need interpreter because you can just type eval. Flyweight, never. Bridge, never. I don't know. Those are the 7 for me. Those are the ones. Sometimes you use a pen, you don't know what it is. If you ever wrap the class, like facade, decorator, and adapter, if you just look at the class diagram, they look like the same. You're wrapping an object with another object.
Right.
but the three differ in purpose. Facade is to combine or to change the way you interact with something. Sometimes facade on many, sometimes just one. Adapter is specifically to make it look like a different one.
Right.
And then decorator is to take an existing and add more functionality. So you export the original, but you put something else. And that goes back to open close rule. If you decorate something, you don't change the original, but you can add to it.
Mm-hmm.
So that's an example of how the decorator does open close. But all three of those, if you just look at the class diagram, oh, this is the same pattern. It's the same structure. You have a class that wraps another class.
Yeah, but
three different contexts, three different results.
Right.
So chances are, guys on the team, you've probably done one of those and there might be another wrapper design pattern. You guys have probably used that. Hopefully, you've used that, but you didn't know that it was a pattern. But it is a pattern because you guys all did it.
Mm-hmm.
All right, go ahead. Yeah.
Like they're like I think out of all of them, like there's a bunch. Like I remember reading the Bingo 4, like many years ago, and thinking I never used this. Like it was like the second half of the book.
Mm-hmm.
It was like, yeah, I don't think like any of these are very useful, or like they were like so specific.
Yeah.
That was like, I don't know.
Yeah.
And some of them I feel they were specific to see.
Like I said, those three wrappers, those are
I mean, if you think
those are used a lot.
I mean, singleton is a pattern. Is it the same?
Singleton's a pattern. Singleton, if you ever make a global object, that's kind of a singleton.
Right.
It's a bad singleton. Or actually, a singleton is a good global, or not a good. A singleton is an acceptable global object.
Right. Which, by the way, I was doing recently. I put it recently, and because of the caching of Rails, I realized I couldn't use it. I implemented it, and I was like, "Yep, no, it backfired."
Oh yes.
But it still gave me kind of like even it doesn't work as a singleton anymore. It still gave me a unified way to grab some values, and again, encapsulated some kind of variation away from anybody who's going to use the class. So in the end, it helped.
Mm-hmm. All right, guys, questions, comments? Andrew, say something. Say something as our junior member.
Yeah, this is...
And it's okay if the answer is, what the hell are you guys talking about? That's legit.
The theme of my answer is yes, it's along those lines, because I'm still trying to understand Bridge, which is not the easiest one to understand. I still have the UML diagram in my head.
Yeah, Bridge or Visitor are probably the hardest two patterns to wrap your brain around.
Oh, Observer pattern, that's another one.
Observer is something I'm sure half the people team have implemented, but never knew that's what the name was.
I've been spending the past 10 minutes just looking up these random patterns.
Yeah.
One of the themes right now that the author is going through is the Alexander implementation, I would call it, where it's like you build from one pattern and you try to find other patterns. And I'm trying to think, how would I do that with something like basic as adapter? Does that build?
You know what I think? The hard part of this chapter is it's not a good prescriptive thing.
Yeah.
It's not something the beginner reads and says, "Oh, I know how to do this." It's more like, here's an experienced guy saying, "Well, if I try to retrospect how I do this right, this is kind of what I do." Where it's when you're better, you go, "Oh yeah, that's what you do." But it's a terrible thing to give a beginner and say, "Okay, read this and go." You just can't. And I think this is true for almost anything of a relatively higher skill level, where you almost can't appreciate what's written about it unless you're at a certain level. Does that make any sense? So I think for you, this chapter is like womp, 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 some high level thing that I hope I can do sometime.
Yeah, if I had like done a project where I implemented as many patterns, I know that sounds very noobish to say because that's not how you code. But if there was a way to just say, hey, this is a good project where you try to use every single pattern, and I grow a taste for what patterns are useful in certain situations,
Yeah.
I can then understand this a little bit.
And that's exactly, I think, when he's talking about, oh, you can see, look at the problem, see what patterns is. This only happens after you've made them. And it helps if you actually, like I said, any of you guys that will come across a pattern and someone will go, oh crap, I did this. But once you have a name for it, that's a pattern you know well. Because if you came up with it on your own, you figured it out from whatever the situation and the things you had to balance, that this was a good answer. It's like for me, I invented composite pattern long before I heard of it. And so when I read the pattern, I said, oh yeah, I know this pattern because I had to make it, right? And so now, after the fact, you can see this pattern where it's appropriate because you already have the knowledge it took to make it, right? But if you hadn't made it, you may or may not recognize it. So actually, composite's relatively easy because there's characteristics you could probably, but there's a checklist you could ask yourself. Hey, do I have things where objects are sometimes composed of other objects, but they all act kind of the same way, and they often have multiples of each other? If the answer to that is yes, that's a composite. But even then, right? And so I think this chapter is useful for those guys who have had enough experience. Oh yeah, we kind of do this one, but I think it's almost useless if you're not at the experience level to nod your head. Oh yeah, this is what you do. I don't know if anyone else sort of sees that. And I think that's some of the difficulty in here. And again, here's a guy who both programs a lot and then teaches a lot. So he has an experience level that is different than some guy who just got out of college. And you ever been in college? I remember taking the circuits class at MIT, and the professor would go up and he said, "And by inspection, we see this." And I go, "What? I don't see that." But I repeated the class, and then the second time I said, "Oh yes, by inspection." After doing all this homework and taking the class twice, I did see it. But I remember being totally like angry. What do you mean by inspection? I don't see that at all.
All right.
Yeah.
I need to go in different.
Oh, that's right. He's got another meeting. Okay. We'll wrap this up. We covered all the questions. Scott is next session. So if there's no other questions, we'll just wrap it here. All right. Thank you. Thank you. Enjoy.
Thank you.
Go nest some loops.